Okay. 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 Entonces, the idea is you have a basic function without transformation. Okay. 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 However, we study what's going on when you apply some transformation. Okay. Basically, we have only 4 kinds. Well, we study 4 kinds of transformation. No? In general, we have more, but no. The most important is 4. So number 1 transformation is when you adding one number outside the function. Okay, when you adding. For example, suppose f of x, que es de parábola. Are you familiar with this guy? And suppose this is the basic. Now I do something plus 2 or plus something or plus 3, any number. And what's happened with the new one after the transformation? Okay, it's obvious. We're using the common sense, but I want to show you in detail now. Okay, we have something like that. So any point on the curve is moving up 2 units because 2 is positive. And what happens if it's negative? I'm moving down. Okay, so this is the idea. Let me show you in detail this idea in Desmos. No, I have prepared for you now Desmos. Okay. Suppose now when the A is a number, it's a positive number, the motion is up. When the A is negative number, the motion is down. And the name of this transformation is vertical shift, shift or translation, whatever you want to call. And the direction is up or is down, depending the unit you add in. See, it's plus 2, so you add in 2 units up. See, it's minus 2, you subtracting 2 down. No? And the point is transforming in that way. Look, this is my original x comma y. And when you are doing the transformation, let me use that symbol to indicate transformation. The x component stay the same, but the y component no, is addition plus the number or subtraction, depending the sign. No? Si A is positive, it's up. Si A is negative, down. Okay, let me show you. To confirmation that everything is clear, let me show you in Desmos. I prepare for you one Desmos. And let me share the screen for the Desmos now. Okay, Desmos now. Switching to Desmos. And you see in Desmos now, again, the famous is in red color. You see the famous parabola, no? X squared, the quadratic function. Now I want to do something, suppose, transformation. Entonces now transformation, in this case, a black color. I want to change just 8, que A is the number outside, plus 8. When you move this to the positive, it's vertical shift up. And when it's negative, it's vertical shift down. When it's negative. When it's 0, well, okay, so when it's 0 happy, the 0, 0, 0, 0, 0. They are perfect coincidence in between the basic and the transformations and no transformation. Everyone follow me? Do you understand the idea or it's confusing? Confusing, clear, confusing, clear, confusing, clear. Clear? Okay. Confusing. What part confusing, please? Who's that? What part confusing? Activate the microphone and ask me directly. Come on. What part is confusing? I just lock the middle of the problem. I just lock the middle of the problem. ¿En Desmo o en whiteboard? Answer me. What's the problem?
I logged in when you were solving already the problem, so I missed the half of the explanation. This is why it's confusing.
I understand. No, if you want, I repeat again for you, miss. Okay.
Thank you.
No, pleasure. Look, we are studying today transformation. And transformation is a very complicated topic, guys. It's important in the test. Okay, so we have a basic function. This is the basic function. The basic function means basic B. This is basic function. It's the function without transformation. But I want to do some transformation. What is the first transformation we studied? When you addition plus one number. If this number is positive, the transformation is going, so it's vertical shift. The motion is obvious. And when you adding or subtracting outside the parentheses of the function notation, it's obvious that the motion is vertical because you affect only the y value, no the x. The x stays the same. And when it's positive, it's up. And when it's negative, it's down. Okay? This is the thing that you need to understand. I don't know if you reach to see in the decimal the motion. You see or no? Yes or no?
Yes, I saw the decimal.
You saw. Okay, super.
Thank you.
Okay, now number two transformation. We have four transformation. We study theoretical first, and after we see several examples. Is when you adding or subtracting, pero inside the parentheses. And we this study what's going on when the B is positive and when the B is negative. Okay, but okay, I don't want to anticipate anything. But for me, it's clear. For me, it's clear that when you adding or subtracting inside the parentheses, you affect basically the X component, no? Entonces horizontal. Horizontal. At least you understand very well horizontal shift. Que the motion now is not vertical. No, it's horizontal because you affect the X component. And the Y component, I suppose, can stay the same. Okay, but in what direction? In the horizontal, we have two possibilities, right, left, no? So let me go to decimal to understand this idea. Okay, look. Switching to decimals. Switching to decimals. Okay, super. Now I change B. B. When the B is positive, pay attention. When the B is positive, let's see what happens. Ooh, the motion is to the left. Maybe it's a little bit different to your common sense to indicate you, but no, it's a fact. It's to the left. And when it's negative, it's to the right. Okay? Let me summarize this idea in the whiteboard. In the whiteboard, we have that situation. Okay, I understand very well. Okay, the horizontal shift, but when the B is positive, we move to the left. And when the B is negative, you move to the right. We saw in this one, clear. Now, in the point, to understand the point, I suppose that X, Y represent any point in the basic. This is the basic without transformation. And this is the transformer. Okay. Now, the transformation, using this symbol to indicate transformation, is you affect the X component now, pero en opposite sign. Si B is positive, is subtraction, minus B, comma Y. And Y stays the same. That is logical because the motion is horizontal. So Y stays the same. However, X change, but in opposite direction to the common sense, at least in my common sense, no? Okay, when it's positive, is left, is subtraction. Look, and this situation happen always when you operate inside the parenthesis. Inside the parenthesis, when it's plus, actually, in the point is minus. And outside the parenthesis, no. When it's plus. Okay? Inside, opposite operation. Outside, the same operation. Si es plus, si es minus. But inside the parenthesis, you see graphically, no? When it's plus, it's to the left. And to the left is subtraction because you're decreasing somehow the X component. Make sense? Confusing? Clear? Confusing? Basically, this is the first two transformation. Clear, clear, super clear. Angelina is clear. Okay. Okay. I want to complicate more the thing. Transformation number 3. We have 4, only 4. We multiplication. Multiplication C is a number now. A, B, C, D. C is a number and multiplication the function. Multiplication the function. When you multiplication the function, the thing we are doing, let me see before to define the name, no name now, is let's see what happened with the point. This is the point of the basic function x comma y, and you transform it and you multiply intentionally. You multiply by any number c and multiply outside the parenthesis, no inside. No, outside. And when you multiply outside the parenthesis, you affect the y component and the x component stays the same, but the y component multiplied by c, cy. Let's see. I am a little bit confusing. I need to see in the decimal to understand much better what exactly is the effect, because it's a little bit complicated to understand graphically. But I create decimal for you. Okay. Let me switch into decimal one more time. Okay. Switch into decimals. Okay, ready. Okay, this is, you see decimal, right? Let me restore D value 1, B value is 0, no horizontal shift, no, 0, just 0. Let me put 0. Okay, there you go. Okay, now here. Okay, now I want to change C. C is a factor can multiply the function C. Look at that, C. Here. If you multiply our parabola by 2, by 3, by 4, by 5, let's see what's going on. Ooh, remember, the black color is the transformation, and the red color is the original basic function. Okay? However, you multiply by a number less than 1. This is 4, 5, 6, stretching. This is a vertical stretch, somehow, right? However, if you multiply by the number less than 1, suppose, this is 1, okay, but let's go 1.3, 0.5. Oh. This is vertical compress. That's the technical name of this guy. However, if you multiply by -1 or negative number, look at that. -1, specific -1. This is a reflection about the x-axis. However, if you multiply by negative and multiply by a number greater than 1, so we are doing two actions. We are doing reflection and we are doing vertical stretch. Vertical stretch and reflection. Number less than 1, in this case, is vertical compress and reflection. In this case, is just vertical stretch. And this is vertical compress. When you multiply 0.1, it's vertical compress. Okay, this is the technical name. Exactly the same that you can see when you read the book. Okay, maybe you say, well, professor, I don't understand very well. So you pushing down or you pushing up. No. Okay, look, let me come back to the whiteboard. Whiteboard. Look at that whiteboard. Okay, whiteboard is. Okay, there you go. Whiteboard. Okay, basic is several actions. We have vertical. It's obvious it's vertical. And the reason it's obvious it's vertical because you affect the y value. Look at that. You affect the x value stays the same. When you change x, entonces es horizontal. But when you change y, it's vertical. Entonces we have different possibility. Stretch. Stretch is when the c is greater than 1. It's a stretch. When the c is 2, 3, 4, 5, my parabola que normal is like that. Now it's stretching. It's a little bit narrow. Parábola, right? Now, if C is a number and between 0 and 1, o sea, 0.5, 1/2, 1/3, entonces compresa. Y si es negativo, es reflection. Reflection, pero reflection about x-axis. For example, the classical parabola. Again, parabola is super easy to understand. This is x squared. When you affect x squared by -1, it's obvious that our parabola look like that. A reflection about x-axis. So x-axis behave like a mirror. Okay? Okay. Everyone follow me? You are lost? Complicated? Easy? Piece okay? Piece of rock? I understand it's hard. But a little bit you take your brain to the new situation. It's okay. Okay, Sabrina says it's okay. Okay, Sabrina. I trust to you, Sabrina. Okay, number 4, follow. Angelina is following. Okay. Now the last transformation is when you multiply, but inside the parentheses. Inside the parentheses. But I know because we studied before. When it's inside the parentheses, look at here. It's opposite operation. Basically, it's horizontal something. Horizontal something. I don't know exactly what's going on, but it's horizontal because you affect the x component. And y component, no. So the transformation is affect only in the x component, like that. Look. This is x comma y. This is my original function. And you transform it like that. X divided by the y divided, professor. Because of multiplication. When it's multiplication, it's division. Exactly the same happens here. When it's addition, it's subtraction. When it's subtraction, it's addition. When it's multiplication, it's division. And when it's division, it's multiplication. So inside the parentheses, we always expect opposite operation. Okay? Because you affect the x component. Pero I don't know exactly si es stretching, si es compressed, si es reflection, I don't know. So let me try to see en después. Okay, en después. Okay, después again. But I propose you now, no working with the parabola, because parabola is good, but much better to see the effect is in the square root function. And this is the square root, the classical square root function. Guy, you can find any function in the document I sent to you before. Last time was I sent the library of the most common function that we are working, and you need to be familiar, no? With the okay. So let's do the modification D. Okay, but I want to study here. Oh, what's going on? Because I changed D1. Let me put D1 so it doesn't affect. This is 1, 1, 1. Go. No transformation. So no transformation is A0, B0, C1, D1. So this is the original function, right? Now I want to change D, que is inside the parenthesis. In this case, you know, radical symbol working like a grouping symbol. Entonces, when you affect inside the radical symbol, is in the function notation inside the parenthesis. Let me see. Pay attention. What is the effect? And we try to find conclusions of this. Suppose que D is greater than 1, 2, 3, 4, 5. Suppose now que D is less than 1. Suppose 0.5. 0.5. 0.5, 0.5, 0.1, 0.5. No, too much. Okay, 0.5, 0.4. And when it's negative, es reflection. Exactly -1. Let me try -1, -1, -1. Let me try -1, -1, -1. -1 is exactly reflection, but this reflection is different. It's reflection about the y-axis. Okay? So let me summarize. Let's come back at the beginning. No transformation. D1. Okay, 1 is invisible, no multiplier. Now suppose I change. Suppose 2. 2, 3, 4, 5. Oh, I suppose, professor, look at the picture. Okay, this is a horizontal compress. Because in my mind, look like a one guy pushing the curve, compressing onto the y-axis, compressing, pushing. However, so you don't see very clear this idea. Let's move in. No, let's doing factor less than 1. Suppose 0.6. Oh, it is more clear que somebody pull. This is a stretching, horizontal stretching. What about when it's negative? When it's negative, a reflection. But what kind of reflection? Well, in this case, a reflection about the y-axis, but we have a combination, reflection and compress. Reflection about the y-axis and compress, horizontal compress. Okay? This is horizontal stretch and reflection, maybe. There you go. Look at that. Okay, it is a negative 0.2. Okay, I understand now. Okay, let me summarize in the whiteboard this idea. Okay, whiteboard. Okay. So we have again 3 possibilities. It's a stretch, compress, and reflection. But this reflection is different because this reflection is about y-axis. So what is the condition for a stretch? It's when the D is in between 0 and 1. Completely different to here, a compress. This is a stretch. Sorry. This is a stretch. When the D is greater than 1, it's compressed. And when the D is negative, it's reflection. Okay? This is the big picture about transformation. Just to understand this, can look like very complicated, I bring for you several examples. Example 1, example 2, example 3, example 4, 5, 6, 7, and 8 example. Any question? Okay, let's move on to the example. Okay, the first example is given somehow. Example 1, look, is given the equation of the function. So the function is f of x is equal square root x plus 6 minus 5. The first thing you should do is identify what family belong that function. So what is the basic function associated with this example? Well, I suppose it's the function square root x. Yes or no? This is the basic without transformation. This is easy, right? Yes or no? Identify. And the library that we have, so you say, well, no, this is a, okay, identify, clear, okay, super. And after we are doing, we discover, we analyze what kind of transformation we have. Okay, the first transformation 1 I saw is plus 6. It's something like that. And you have the function, you put plus 6. Okay, plus 6. And what is the reason, professor? Can you write this plus 6 first and 5 after? Because according to the order of operations, the first operation that you perform is the operation inside the grouping symbol, in this case is square root. Okay? Suppose you plug in one number here, 2. 2 plus 6 is the first operation. After you find the square root, and finally subtracting 5. This is transformation number 1. And transformation number 1, I can see is horizontal shift, 6 units, because the number is 6. And what direction? To the right or to the left? To the left. How do you know it's left? Because it's plus. Left. Very well, Angelina. Very well, Angelina. Left. This is transformation number 1. And transformation number 2, is f of x plus 6. Maybe you see more clear in the function notation. Minus 5 is vertical. Vertical shift 5 unit. In what direction? To down, because it's negative 5. Because it's negative 5. This is the idea. We can do the U identification, and finally we do the graph. We can do in decimal, or we can do in by hand. Let's do in decimal, no? Que it's easier, more clear. I don't know. Well, let's do it by hand. I know, by hand. Okay, this is my original. So you start doing by the suppose xy. This is the basic function. Case square root can look like that. Ooh. Domain is only positive number because the square root negative number is imaginary and do not exist. And you select 3 point. 3 point is enough. 0, 0, 1, 1. How do you know? Because square root 0 is 0, no? Square root 1 is 1. This is the x value, this is the y value. And square root 4 is 2. This is 1, 2, 3, 4, 2. Okay, this is the point 2, and this is the point 4, 2. This is the basic square root function. When you perform the transformation number 1, the transformation number 1 is a horizontal shift 6 units to the left. Because any to the left, any x component is decreasing minus 6. Okay. Let me show you in detail. Okay, this is my rectangular coordinate system now. And let's do it point by point. This point is 0, 0. Now that point would be minus 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 6, 0. The reason was I decreasing subtraction because I left 6 units to the left, point by point, but it's horizontal. Horizontal means x component. So x component 0 minus 6 is minus 6, and 0 stays the same. The y component doesn't affect. Likewise, that point is negative 5, 1. Negative 5, 1. And this is negative 2, 2. 1, 2. Negative 2, 2. This point is the point, negative 2, 2. And we connecting, okay, somehow. This is the graphic of the first part after the first transformation, case square root x plus 6. I want to do by hand, but in decimal we are doing super easy. 1 second. In 1 second. Let me show you after that. And finally, subtracting 5. Subtracting 5 down is that the y component point by point is decreasing 5 units. Okay? Entonces x es y axis. That point que normally is minus 6,0 would be now minus 6, -5. 1, 2, 3, 4, and 5 here. At this point, it's minus 6, -5 because you transform it. The second transformation is vertical shift 5 units down. So this point is minus 6. Minus 6 stays the same because of vertical, and the component y is subtracting 5. 0 minus 5 is minus 5. Okay, the second point here is -5, 1, but actually is -5, -4, no? Because 1 minus 5 is -4. -4 is -5 and -4, something like that. This point is a point, -5, -4. And the last point is 2, -2,2 is -2, -2, -2, -2, -1, -2, -2, pero in this case it's 2, and 2 minus 5 is -3. Here, -3. This point is the point, -2, -3. So when you connecting our graph, it look like that. And this is the final answer. Final answer. We are doing transformation by transformation, step by step, sequentially. Transformation number 1, transformation number 2. End the story. Do you see that or no? Complicated or easy? I promise. Let's do it now in Desmos to see super clear. Complicated, Sabrina. No. You are smart, Sabrina. No, it's not complicated. Let me simplification with Desmos. Of course, it's not complicated. Okay. Let's do it. Let me switch into Desmos to see clear the idea. This is a piece of cake. Remember, we have our fantastic graphic calculator que es Desmos. Do you see Desmos? I am confusing about how you got the point. Bueno, using the formula. Okay. I come back again, Sabrina, to the point is using the common sense. Look, suppose. Okay. Let me open a new without. Okay, new Desmos. Okay. This is y equal square root x. Square root here in the keyboard. Square root x. This is a square root x. Super. I want to perform transformation by transformation, step by step. Y equal square root x plus 6. X plus 6. Wow. Look at that in blue color. What is the transformation? The transformation was horizontal shift 6 units to the left because it's plus. So the mnemonic divide that you need to remember when it's inside the parenthesis, it's horizontal and it's opposite signs. It's plus, is to the left. And finally, the second transformation is y equals square root. I stay the same on x plus 6 because I want to perform the second transformation, que is outside the radical, -5. No? -5. And -5. Oh, look at the in green color. In green color was the vertical shift 5 units down because it's negative. The point. Look, you click on the curve, 0,0. This point is here. You click here, and the corresponding point, -6. Okay, and you click here, and the corresponding point, bang. What's going on? Bang. Doesn't work. All right, let me see. -6, -5. You can plot the point if you want, no? Okay, -6, -5. Sabrina, more clear now or no? More clear now or no? Sabrina? It's okay. It's okay. I feel like acceptable. Pero it's okay. Okay, basic. So let's doing another example. que maybe much better clarify the idea. Look, another example. Example 2. Example 2. But the example 2, you help me a little bit. Example 2 is y equal minus x minus 5 square plus 3. Okay. Question number 1. Question number 1. So what is the typical question here? Is when doing the transformation, try to do step by step the graph of this new function. But my question by myself is, what basic function belong this guy que es a family? Bueno, I suppose que es the function x squared, because I see a square here, right? No square root, no cubic, no, okay. This is a family. So we start for the basic parabola. Okay, let me analyze. What is the transformation number 1? What is the transformation number 1? Okay, you can see. What is it in your opinion? Remember, it's following the order of operation. What is the transformation number 1 in your opinion? Looking this equation. No idea? What is the first transformation? How many transformations you can see? How many? How many in total? Guys, are you there? Two transformations. Nobody have no idea? We have 3 transformations. 3 transformations. Why? The first one is x minus 5. When you plug in here one number, the first operation you should do is subtracting 5. So the first operation, this is f of x. Now, and the second step is x minus 5. Okay, this is the transformation. And this is obviously the horizontal shift. 5 unit. In what direction? To the right or to the left?
To the right.
To the right. Very well, because I know by memory que con el minus es to the right. So my new parabola look like that. And this point is super important, is 0,0, actually now should be 5,0. Okay, everyone follow me so far? We are doing a first transformation. The first transformation. What is the second transformation? What is the second transformation? Transformation 2. Well, I suppose it's this minus, no? And this minus is like a reflection. But a reflection about the x-axis. The x-axis. That my new parabola now look like that. Okay, this is f of x minus 5, and you introduce now a negative outside. And this is reflection about x-axis. Okay? Finally, transformation number 3 is plus 3. It's a coincidence que es transformation number 3 and the number is 3. Entonces, what kind of transformation it is? When you adding plus 3. O sea, es minus f of x minus 5, now plus 3. This 3 is outside the parenthesis. Entonces, when it's outside the parenthesis, I know que es vertical shift. Vertical shift, 3 units. But in what direction? To the nothing, no? To the what? In what direction? To
down?
No, because it's positive. And when it's positive, it's up. When it's negative, it's down. Make sense or no?
Yes.
Using your common sense. This point is 5,0, and when you add in 3 outside the parent, you add in 3 and the y component. At that point now is 5,3. 1, 2, 3. Here, that point is 5,3. And the parabola is going down, of course, up and down. Exactly the same. The only thing we are doing is 3 units up. What is the reason it's up? Because 3 is positive. Okay, guys, that's the only thing that you need to memorize is when you're adding one number, positive number, outside the parentheses, is vertical shift. So you're subtracting, it's down. Okay? So your addition is up. This is vertical. This is vertical. Outside vertical. Inside the parenthesis is horizontal because you affect the x component. Si es minus, is to the right, and si es positive, is to the left. More clear or not clear? Do you want to see the process in decimals? This is the beauty of this. Okay, you don't know anything. However, you open decimals, and you can do step by step. It's our fantastic graphical calculator. Free, and we can use it anytime. This is do you see decimal, right? Yes or no?
Yes, Professor.
Okay, y equal, I put it the original function is square, power 2 here. Parabola, the classical parabola. Let's do it transformation by transformation. Y equal, the first transformation, it's important that you follow in the order of operation, is x minus 5, inside the parenthesis, x minus 5. Close the parenthesis and raise to the second power. Bang! Look at that. This is the black color. This is my new parabola. Super. The name of this transformation was horizontal shift 5 units to the right because it's minus. Okay. Now I copy the next transformation, get y equal. Now I introduce a minus here. It's x minus 5. Minus 5 again, the same idea, x minus 5. Close the parentheses and raise to the second power. I have the power here in the keyboard. Power. Okay, there you go. Oh, what's going on? Oh, it's down. Look, the red one is after the reflection. So this minus, the action for this minus is the reflection. Finally, plus 3, no? Okay, let's do it. Y equal minus parenthesis x minus 5, close the parenthesis, power 2, power 2, square, plus 3, no? Plus 3. Boom. Plus 3 is, plus 3 is vertical shift 3 units up. Let me track the famous point 0,0. This is 0,0. After the first transformation, get black color is 5,0. 5,0. After the reflection, doesn't change because 0 have no sign. When you change the sign of the y, the point 0,0 stays the same. And final plus 3. This point is 5,3. End the story. This is transformation point by point. Any question? Super clear. Okay, let me try to spend the 5 minutes that we have, wow, and to do at least one problem or two problems similar to the decimals. Decimal in that part is very, very complicated. Okay, it's given, for example, one graph, no equation. One graph is given like that. Look, let me show you. Suppose, sorry. I switching whiteboard now for you. Good, very good. Okay, look at that. Okay, suppose in Alex is a bad guy. Alice give you the graph of the one function. Let me try one easy to start. No equations, you know, the graph is given. Suppose -2, positive 2. We have the point 2, 3, and 4. This the first point is 2,2 minus 2,2, and this is 2,4. Entonces our function is like a one segment line, and they call that function like a y of x, and they want you are doing the transformation y equal to g of x, so multiplication by 2. Immediately you recognize wow, multiplication by 2 outside, you affect the y component. This is typical vertical stretch. Because you multiply by 2 outside the parenthesis, y outside means y component. At that point, for example, que es 2,4, actually should be 2,8. 5, 6, 7, 8. At this point now it's 2,8. So the x component doesn't affect, stay the same, because the transformation is outside, is the y. And the y component, yes, duplicate. Likewise happened in the other point, que es negative 2,2 should be negative 2,4. Negative 2,4, I suppose que here. That point is negative 2,4. Okay, now my transformation, let me use another color, green color. Look like that. Do you understand this or no? So actually, we are doing only one transformation. Only one transformation that was vertical stretch. Do you understand or no? Yes or no? This is typical Desmos problem. Typical Desmos problem. Let's do another okay? Involve only one transformation, guys. This is the last problem, I suppose. Suppose the function is given like that. Suppose f of x is given by graphically, okay, something like that. This is 1, 2 again, 1, 2, negative 2. And this is 2, negative 4. Let me see. 1, 2, 3, 4. This point is the point 2, negative 4. And this point is the point negative 2, negative 4. And the graph is including the origin, 0, 0. This is my graph in blue color que corresponde with this function. I want to do the graph in green color of the function que es y equal, this is y equal, now y equal f of x, but you divide by 2 inside the parenthesis. Wow, divided by 2, so inside the parenthesis is horizontal. Horizontal T, horizontal something, horizontal compress or horizontal stretch. You need to remember, see the coefficients in that case is 1/2, so we can consider it, okay, this is 1/2 x, and 1/2 in decimal is 0.5. So actually, the thing that we are doing is multiplication by 0.5. Entonces es basically horizontal stretch. Horizontal stretch. Is, remember, this is confusing. Is, see, you have x, y point. When you are doing a transformation, you have divided by 0.5, que es duplicate x, and y stays the same. Because it's divided by, the formula is x divided by d, but d is 0.5, 1/2, flip it, it's twice. Okay, entonces es easy, in my opinion, because you duplicate the x component. At that point it's 2, negative 4. No. Now it's 4, negative 4. At this point. This point is the point, 4, negative 4. And here, exactly the same. Duplicate, but x component, negative 4. Negative 4, this point, new point is negative 4, negative 4. It's a coincidence. Entonces, the actually 0, no. 0, stay the same. because 0 multiplied by 2 is 0. Entonces, the new graph look like that. And maybe you see more clear, maybe you see more clear now the idea for the horizontal stretch, because this is like a, you know, umbrella, no? Umbrella, o sea, the blue umbrella. And when you apply the transformation, this umbrella stretch a little bit in the horizontal direction. Do you see or no? Do you see or no? Okay. Guys, sorry, the time is over, you know, it's too small time. Well, don't worry, I prepare. So we, next time, Wednesday, we cover the last topic, and after we dedicate the entire week to do the review. The review include this thing we are covered, plus another thing we don't cover, but we cover everything in the review. I am very, very concerned with this class. You are good. You prove me that you are good because you are doing very well. The majority, the super majority of you are doing very well in the text, in the Alex. Okay, so the background of you are good. However, I am concerned because there is short time the lecture. So any question that you have about Alex, please let me know by email. If I answer you, he send back the solution. Okay, don't hesitate. I am your friend. I am your friend. And also, and also the tutor. No, you can either way. No, you reach me or try to reach the tutor. Okay, guys, thank you so much for your attention. Let's see again Wednesday. Okay, pleasure.
Good day, Professor.
Take care.